Welcome to the Programming with Python course. Python is a versatile, high-level programming language available on multiple platforms. It's a language that's used by companies large and small to build a diverse range of applications. Areas that Python is used in include web development, data analytics, and business forecasting. The Python programming language syntax is very similar to English. It's intuitive and beginners will often quickly understand what's going on. It's also a great choice for experienced programmers who will appreciate its power and adaptability. Because Python is a very popular software development tool, it's important for you as a new developer to know how it works and to know how to code with it. This course covers the key points you need to know to begin programming in Python. Starting with Module 1, you'll get started with a Python programming language and associated foundational concepts. You'll learn to recognize common applications of Python, and you'll be able to explain foundational software engineering concepts, use operators to program output in Python, and use control flow and loops to solve a coding problem. And in Module 2, you'll build on what you've learned in the first module by learning about the core concepts that underpin the Python programming language, variables, and different data types in Python. And you'll get to use control flow and loops to execute code under specific conditions. This module also introduces you to working with functions and data structures in Python, recognizing errors, determining their causes, and deciding how to handle them, and creating, reading, and writing data in files. In Module 3, you'll learn about the programming paradigms of functional and object-oriented programming. You'll use functions to explore algorithmic thinking. Furthermore, you'll learn how to work with objects, classes, and methods in Python. Then you move on to dealing with modules, packages, libraries, and tools in Module 4. Here you'll learn how to find, import, and use popular Python modules and packages. Leverage powerful tools to optimize the programming workflow. You'll discover different types of testing and their features, and you'll be able to use testing tools to write a test. Module 5 is the graded assessment where you get to demonstrate your Python coding ability. You'll be able to exercise the skills and knowledge from this course, and you'll have the opportunity to reflect on the course content and the learning path that lies ahead of you. You may have encountered some concepts or terminology in this video that you don't fully understand. Don't worry about that right now. This course is designed to address all such issues and give you a solid coding foundation in Python. Enjoy the course. Computers and their programs are integrated into our lives at a scale we could not have imagined. Over the past 20 years, we have seen dramatic jumps in technological gains in areas of distributed computing, cloud computing, and AI improvements such as voice and face recognition and self-driving cars. In the next few minutes, let me give you a brief overview of the history of programming, and you will also learn the basics of how programming works. Computing dates quite far back in our history. Charles Babbage in 1822, while studying at Cambridge University in Britain, was working on bettering calculating devices such as navigation charts and astronomical tables, which at the time were used by many ships at sea. Babbage came to the realization that all these calculating devices contained various amounts of human error, and he wondered if there was a better solution. His solution was the difference engine. The difference engine used mechanical gears with numbers 0 to 9 etched onto their gaps, separated by gears' teeth. Its key function was to carry out one operation that was computed by manually moving hand cranks until the final answer was revealed. After building a working prototype, Babbage spent many years working on further improving his designs and constructing improved versions of the original idea. He created another device called the Difference Engine 2, but ultimately produced a new and better concept called the analytical engine. The analytical engine is widely accepted as being the basics of modern-day computing. Babbage's friend Ada Lovelace published a document describing how the analytical engine could perform a sequence of calculations, which is essentially what a computer program does. However, the analytical engine was never completed, and Babbage, like a lot of developers, did not invest in good documentation. With the historical side of things covered, let's now delve into understanding what programming is. Before I explain programming, it's helpful to understand how computers work at the most fundamental level. Computers only understand binary code, which consists of 2 digits, 0 and 1. This may seem quite strange at first, but with a little explanation, it will all make sense. 0 and 1 relate to different electrical states, similar to a light switch. 0 is equal to off and 1 is equal to on. For example, in programming, when you calculate numbers, cost, or any arithmetic, you mostly use decimal numbers. Every program written needs to be converted to binary code or machine code. An example of decimal to binary conversion is decimal 1 is binary 1, decimal 2 is binary 1, 0, decimal 3 is binary 1, 1, and so on. A computer represents the binary code by using tiny electrical conductors called transistors. These transistors are housed inside the Central Processing Unit, CPU, which is essentially the brain of the computer. When a program is written using any type of language, it needs to be compiled or interpreted. The outcome is to turn readable programming code, for us, into readable programming code for the computer. It's essentially extremely hard for humans to read and understand binary, and therefore, using it is error-prone. It's far easier for us to read and write programming languages. So, what is programming? Programming is the ability to provide a computer with a set of instructions in a particular language that it can understand and perform those operations or tasks. In other words, you need to tell the computer what you want it to do in a format and language it can understand. Programming is a skill. The more you practice and learn, the better you become. At first, it can take quite a while to write straightforward programs. As you progress, you'll become more familiar with the language and how the logic and conditions should be applied. Programming is also a creative skill. That's because you can write computer programs to solve problems in many different ways. And that brings us to the end of this video. You now know the brief history of programming and how typical computer programming works. Would you like to be able to program on different platforms, for example, Windows, Mac, and Linux, in an easy syntax similar to the English language? Then Python is your solution. It's a high-level programming language that works on many different platforms. By the end of this video, you'll know the benefits of learning Python and understand where to use Python. Python was created by Guido van Rossum and released in 1991. It was designed to be readable and takes a lot of similarities between the English language and mathematics. Since its release, it has gained greatly in popularity and supports a rich selection of frameworks and libraries. At present, it's currently one of the most popular programming languages to learn today. It's widely used in all areas of business, such as web development, artificial intelligence, machine learning, data analytics, and various different programming applications. Python is also very easy to learn and get started with. Given that the syntax resembles the English language, it makes it easier to read and decipher. Programs that are written in Python also require less code in comparison to programming languages such as C or Java. One of Python's key advantages is that it makes developers very productive and allows projects to be completed more quickly. Creating good software that is used by many is hard and very time-consuming. The simplistic nature of Python abstracts a lot of complexity away from the developer to allow them to focus on the task at hand. Given the language is quite easy to understand and pick up, it can be an easier route to market for new programmers starting out to get something produced in much less time. Compared to some other languages, Python has a much easier learning curve. It lends well to the philosophy of write less, do more. Now that you can describe the benefits of learning Python and where it can be used, it's also good to know that Python developers are in high demand. Becoming a Python developer makes for a good career choice.
When you start using Python, it's important to make sure that it works correctly on your operating system with your chosen Integrated Development Environment, or IDE. In this case, Visual Studio Code, or VS Code. So, an essential step in using this software is to make sure that the right version of Python is used as the interpreter when running VS Code. In this video, I will demonstrate how to set up VS Code on Windows and make sure that it points to the correct Python interpreter. So, I start by opening the VS Code editor. To do this, I click on the Windows icon in the taskbar, which brings up a menu. I then type Visual Studio Code in the search bar. The best match for the search is the Visual Studio Code app, which I click on to open. VS Code is now open. Next, I select Get Started with Python Development. This is a useful guide to setting up Python on the VS Code IDE. The first step in the guide is to install Python. I already have Python installed, and I can verify it by typing python --version in the terminal. To open the terminal, select the Terminal tab on the top menu and choose New Terminal. After I press Enter, it displays Python version 3.10, which is correct. The second step in the guide is to create a Python file. I do this by clicking on the Create a Python File option in the guide menu, and then clicking on the Create Python File button that appears. Next, I put in a print statement by typing print hello world. I will explain what a print is at a later stage, but for now, you just need to know that it's for printing out a value within the terminal itself. Now I save this as a Python file in my root level directory by clicking on File, Save As, and then entering the file name helloworld.py. py is the file extension I have to use when saving a Python file. The next step in the guide is to select a Python interpreter, and I click on this option in the guide menu. And then I click on the Select Python Interpreter button that appears, which brings up all the versions of Python I have installed. I do this because I want to make sure that when I run the Python script, it will choose the correct interpreter. The version that comes up is Python version 3.10, and I set this as the interpreter because it is the most recent version. To test and verify that everything is working correctly, I have to run the Python file. In the top right of the screen, you'll notice a play button. I close the guide so that it displays better. The play button has a drop-down menu that has the option for running the Python file or running it in debug. I click on the Run Python File option. Note in the terminal window that it has run the file using Python 3.10 as the interpreter, and I get the output of hello world. And that means that I'm now set up to use Python directly in the IDE so I can run and debug my scripts. You now know how to create and save a Python file and how to select the correct Python interpreter to run your files in VS Code. When you start using Python, it's important to make sure that it works correctly on your operating system with your chosen Integrated Developer Environment, or IDE. In this case, Visual Studio Code, or VS Code. An essential step in using this software is to make sure that the right version of Python is used as the interpreter when running VS Code. In this video, I will demonstrate how to set up VS Code and make sure that it points to the correct Python interpreter. On my Mac, when I open Launchpad, I type in Visual, or VIS for short, and it opens VS Code. VS Code provides a walkthrough guide for setting up Python. This can be found on the welcome screen. However, if I don't see it in the main view, I can click on More, and then I click on Get Started with Python Development. It brings up the guide I can use to verify that I have everything set up correctly. Next, I check that Python is installed by opening the Terminal window. I click on the bottom left of the screen and then on the Terminal tab. Then I type Python space -- and the word version. When I hit Enter, notice that it returns Python version 3.10, which is correct. By default, Mac comes with Python version 2.7, but this is not the version I want to use. Instead, I want to use the most recent version. Next, I create a simple Python file. To do this, I click on Create Python File in the Get Started with Python Development guide. I put in a print statement by typing print hello world. I will explain what a print is at a later stage, but for now, you just need to know that it's for printing out a value within the terminal itself. Now, I save it by clicking on File, Save As, and then entering the file name hello_world.py. py, or pi, is the file extension I have to use when saving a Python file. Now I have to check that I can run that file, and to do that, I need to set my Python interpreter. So, I go to the Get Started with Python Development guide again, and I click on Select Python Interpreter, which opens up the Python interpreter screen. Here I can choose which version to use from the drop-down menu. Notice that I have different versions of Python installed, but the one I want to use is the one I installed through Homebrew, and it is also the recommended one. To bring up the Python interpreter screen without the Get Started guide, I can press the Command key, Shift, and the letter P. Then, I type in Python, followed by a colon, and I choose Python Select Interpreter from the top of the menu. Then I press Enter. When selecting the version of Python, it's best to choose the recommended one, but make sure that it's the latest version that you have installed on your operating system. Next, I'll run the file. First, I close the Get Started guide. Then, in the top right of the screen, you'll notice a Play button with a drop-down menu, which has the option for running the Python file or running it in debug. I click on the Run Python File option, and then I click on the Play button. Note that the output appears in the terminal. I have now validated that I have VS Code pointing to the correct Python version that I want to use, and that I am able to run and execute scripts directly on the IDE. You now know how to create and save a Python file and how to select the correct Python interpreter to run your files in VS Code.
Did you know that Python can be run directly in the command line on Windows or Terminal in Mac and Linux? In this video, you'll learn more about the core differences of running code from the command line via the IDE, as well as exploring ways in which you can run programs through Python. Let's explore the two main ways to run Python's programs. The first way is using the Python shell, and the second way is to run a Python file directly from the command line terminal. The Python shell is useful for running and testing small scripts. For example, it allows you to run code without the need for creating new .py files. You start by adding snippets of code that you can run directly in the shell. Let's explore the second main way to run Python's programs, which is running a Python file directly from the command line or terminal. Note that any file that has the file extension of .py can be run by the following command. For example, type Python, then a space, and then type the file name with a .py extension. VS Code is a better choice than using the Python shell or running it directly from the terminal because, besides including both of these options, it comes with a plethora of additional improvements that make coding in Python a better experience. Visual Studio Code also offers features such as auto-completion, debugging, and code syntax, highlighting, whitespace, and indentation helpers. I'm now going to demonstrate the different ways that you can run Python programs in VS Code. There are two options to run programs through Python. One is to run directly from the command line or the terminal if you're on Mac. And then the other option is to run directly from the IDE, which in this case is Visual Studio Code. Let's find out how to do this. First, I open the terminal window or command line window from within the IDE by clicking on the terminal menu and selecting New Terminal. Now I run the hello world.py script directly from the terminal. So I can run this by typing the command Python, and then the name of the file hello world.py, followed by the name of the file. Then hit the Enter key. The result is hello world. There's a second option using the terminal, which is entering it into the Python shell. So if I only type the Python, hit the Enter key, it opens the Python shell approach. Here I can write code and run it directly within the terminal window. I can, for example, use the same code that I have above the print hello world code. I hit the Enter key, and that will print out the words hello world directly in the shell. Let's say I want to exit from the shell. I then type in the word exit. As this is a function, I must add the parenthesis, hit the Enter key, and now I'm back in the command window. To do the same from within the IDE, I just close the terminal window. Here I can run any Python scripts from the IDE directly by using the buttons in the top right-hand corner of the screen, by selecting from the drop-down either the Run Python file or the Debug Python file. Now I click on the Run button, and the terminal should open automatically. The result is hello world that is printed. You have now explored the two options that are available for running Python code directly from the terminal or command line and from the IDE. That brings us to the end of this video. You now know the core differences of running code from the command line via the IDE. You are also able to demonstrate ways in which you can run programs through Python.
In this video, you'll explore Python syntax and learn how both whitespace and indentation can impact a program when used incorrectly. In VS Code, I create a new file called python_syntax.py. I start by using a print statement to generate a line of text. Don't worry if you're not familiar with print or variable declaration at this point, as that will be covered later in the course. I type print followed by the string hello. When I click on the Run button, the text hello appears in the terminal panel. Now let's say we want to use another print statement on the same line, which will output the text value world. So I add a space and then type another print statement with the string world, and we expect this to give us the words hello world. But when I click on Run, we actually get an error. Specifically, it says syntax error, invalid syntax. This happens because the interpreter doesn't know when the new line or statement occurs. There are two ways to solve this problem. One is to move the second print statement to another line. I do this by placing the text cursor before the print statement for world, and then pressing the Enter key to move it down one line. When I click on Run this time, there is no error and I get the words hello and world on separate lines. Let me undo the edits I made to my code by pressing Ctrl and Z or Command Z on a Mac, and then try the second method, which is separating the two print statements with a semicolon and a space. When I click on Run again, it also runs both statements as expected. Next, you'll cover the impact of whitespace in Python syntax. I first clear my screen and then declare a variable and assign it a value by typing x equals 1 plus 2. On the next line, I will add a print statement for x. Before I click on Run, however, I'll go back to my variable assignment and add a random number of spaces around the plus symbol. Doing this will not cause any problems with this line. However, issues will arise if I add a new line or an end statement. To demonstrate it, let's input a new line and type +3. Running this code then returns a value of 3. What has happened is that the interpreter has executed our first line of 1 plus 2 correctly, despite the extra whitespace, but it did not account for the +3 on the second line. There are a few ways to work around this issue. The simplest approach is to use a forced line. To do this, I type a backslash at the end of the first line. Now, when I click on Run, it returns a value of 6, which means that both lines have been accounted for. To summarize, any amount of whitespace or indentations on a line is fine, but keep in mind that if you are combining it with additional lines, then you will need to give clear indicators of where a new line has occurred. Next, you will explore indentation in Python. I start by clearing my screen and declaring the new variable name with a string value of John. I want to write an if statement which will return John only if the name variable has a new value of John. I do this by typing if name == John, and then on a new line, I input a print statement for name. To make this program work, I need to have an indentation before the print statement, which VS Code added automatically. When I click on Run, I get back John as expected. But what happens when the indentation isn't there? If I delete the indentation from my code and then run it again, I get the error indentation error expected in indented block. This tells us that an indentation was not found where it should have been. Fortunately, the error message directs us to the specific line where the issue was detected. I could then edit my code and fix it. When writing programs in Python, it's a good habit to read the output whenever you encounter an error, as you are often given the specifics of what went wrong and where it happened, as you noticed here.
Variables are an essential part of programming, and they are used to store all different types of data. You might even say they are the cornerstone of programming. This is because they allow you to work with and manipulate data. Therefore, it's important that you can identify variables and recognize how they are used. Declaring variables in Python is very straightforward. All you need to do is declare a name and assign it a value. The word variable refers to something that can be changed. To do this in Python for a variable that has already been declared, you only need to reassign or redeclare it. Let's explore an example. Let's say the variable x has been assigned the value of 10. To change this, you only have to redeclare it, so it will have the value of 20. The examples so far have relied on simple naming conventions such as x, y, and z. When working on a project with other developers, it will become increasingly difficult to know what these variables mean or refer to. As a programmer, you will write a lot of code over time, and if it's been a few months, you'll most likely not remember exactly what the code was supposed to do. Using generic variables like x and y doesn't give any information about that variable and where it is used. Giving meaningful names to your variables that make sense in the given context will allow you and other programmers to easily understand what's going on. As a programmer, it's important to understand that data will change throughout the life cycle of your program. Whether it's getting user input via a web form or working with variables inside a code itself, the key function of the variable is to keep a reference to some sort of value. Now that you have a basic grasp of variables and their role in Python, let's move on to a more practical demonstration of the variables and how to use them. I'll demonstrate how to use variables in Python, but first, I want to briefly talk about naming conventions. There are different options available to you as a developer when it comes to naming your variables. One option is called camel case. The first letter of the first word is lowercase, and the first letter of every word after that is uppercase with no spaces between words. For example, if I have a variable called my name, I'll put the M of my in lowercase and the N of name in uppercase, with the rest of the letters in lowercase and no space between the words. I can take a different approach with snake case. When using snake case, you keep everything in lowercase letters, but you use an underscore between words. So if I want to make the variable my name, my underscore name would be the result of this approach. Although you have different options as a developer, it's a good idea to be consistent when you are creating variables across your programs. Let me clear the screen so I can begin. So I create a variable in Python by initializing a variable and assigning it a value. All I have to do is name the variable. For example, if I type x equals 5, I have declared a variable and assigned it a value. I can also print out the value of the variable by calling the print statement and passing in the variable name, which in this case is x. So I type print x. When I run the program, I get the value of 5, which is the assignment that I gave the initial variable. Let me clear my screen again. You have several options when it comes to declaring variables. You can declare any different type of variable in terms of value. For example, x could equal a string called hello. To do this, I type x equals hello. I can then print the value again, run it, and I find the output is the word hello. Behind the scenes, Python automatically assigns the data type for you. You'll learn more about this in an upcoming video on data types. You can declare multiple variables and assign them to a single value as well. For example, making A, B, and C all equal to 10. I do this by typing A equals B equals C equals 10. I print all three values separately, and when I click on the Run button again, I find that all three of those assignments have 10 as their value. Again, I clear my screen before I move on to the next example. Yet another option you have is to do multiple assignments. For instance, I type A, B, C separated by commas equals 1, 2, 3, also separated by commas. In this way, I have assigned each of those values to the corresponding letter. So A equals 1, B equals 2, C equals 3. To test this out, I can print all three variables. Click Run, and I'll find that the values 1, 2, 3 correspond to the declaration above. Another important point that you should be aware of is variable assignment and how you can change it. A variable is subject to change. Throughout the life cycle of your program, you will make changes to the value or the assignment of the variable itself, so you need to know how to do that. Let's explore another example. I type A equals 10, and I print that value. After this, I change the value of A to 5, and I print that value too. When I click the Run button, A prints out as 10 on the first line and as 5 on the line below because the value was reassigned. Finally, you need to know how to delete a variable. My variable is A, its value is 10, and I've printed it out. And then on a new line, I type the delete command, or DEL for short, followed by a space and the letter A, which represents my variable. I then print the variable by using the print function, and then I click the Run button. The value is first given as 10 because the variable still existed, but after the deletion, it shows an error saying that A is not defined. You just covered variable naming conventions. Now you know how to declare a variable and assign it a value, and you know how to declare any different type of variable in terms of value. You can declare multiple variables and assign them a single value, and you can do multiple assignments. Finally, you also learned how to delete a variable. That brings us to the end of this video. You can now identify variables and recognize how to use them in Python. Computer systems need to interpret different data values. In programming, data can come in different types. By the end of this video, you'll be able to describe the different data types in Python. A data type is an attribute associated with a piece of data that tells a computer system how to interpret its value. Knowing what data types to use ensures that data is collected in the preferred format. It also ensures that the value of each property is as expected. Python offers raw data types to allow data to be assigned to variables or constants. The 5 main types which are classed as literals consist of numeric, sequence, dictionary, Boolean, and set. Some of these data types can be extended. For example, the numeric data type can consist of types integer, float, and complex number. For now, let's just discuss data types in more detail, starting with numeric. In programming, you need to decide on what type will suit your needs. For example, when working with currency, you are most likely going to use the numeric type of float, as it allows decimal places to be counted. To determine a type of variable, Python also provides a function named type, which will provide the class type based on the variable being passed. Python offers 3 different kinds of numeric types, which are integers, floats, and complex numbers. The integer class represents any non-fractional number, that is, whole numbers with no decimal places. These numbers can be positive or negative, for example, 10 or -10. Floats are numbers that contain decimal places and are represented by the float class. Examples are 10.5 or 6.7. The complex class is used to represent complex numbers which are made up of both real and imaginary numbers. A equals 10 plus 10j. Next, let's explore the sequence data types. Sequence types are classed as container types that contain one or more of the same type in an ordered list. They can also be accessed based on their index in the sequence. Python has 3 different sequence types, namely strings, lists, and tuples. Let's explore each of these briefly, now starting with strings. A string is a sequence of characters that is enclosed in either a single or double quotes. Strings are represented by the string class, or str for short. Lists are a sequence of one or more different or similar types. They are essentially an array and hold any type inside square brackets. Each item can be accessed by its index. Tuples are similar to lists in many ways. They contain an ordered sequence of one or more types, but the main difference is that they are immutable. This means that the values inside the tuple cannot be modified or changed. Tuples are represented by the tuple class and hold data types wrapped in parentheses. The next data type is dictionary. Dictionaries store data in a key value object structure. Each value can be accessed directly by its key. Dictionaries can also store any data type. For example, suppose you declare a variable named ed and assign a dictionary to it. The dictionary contains a grouping of key value pairs. The first pair is A, 22, where A is the key and 22 is a value. The second pair is B, 44.4, where B is a key and 44.4 is the value. You can then output the value of 22 by accessing its key, which is A. Next, let's explore Boolean data types, which are simply represented as true or false. Combined with logical operators, Booleans are used to check whether a condition is true or false. In this example, I'm checking the underlying data type of the values true and false. The class bool is returned, meaning it is Boolean. The last data type is set, which is an unordered and non-indexed collection of non-repeated values. Let me demonstrate an example of this data type. Suppose I assign a set of 4 items to the variable named example set. I then check the type of the value stored in the example set variable by passing it to the type function. Python reports that the underlying data type that the example set variable holds is a set. In programming, data type is an important concept. Variables can store data of different types, and different types of data can do different things. Let's explore these in further detail. Whenever you declare a variable in Python, the data type is automatically assigned for you based on the value of that variable. Let me demonstrate this by typing a variable called a and assigning it a value of 10. To check the data type that has been assigned by Python, I select print and use the type function. I then pass in the variable a as the parameter and click on run. From the output on the terminal, I can see a class of float was assigned because there is a decimal place. Here is another example. I'm using the variable b and I assign it a decimal value of 2.3. To check the data type assigned by Python, I print out type b and click on run. From the output on the terminal, I can see a class of float was assigned because there is a decimal place. This is a different assignment than the standard integer. These are the numeric data types offered in Python. To declare a variable as a string, I wrap the text with single or double quotes. Again, I run the print statement with the function type and pass the variable c as the parameter. When I click on run, the output in the terminal now displays the classes int, float, and str for string. This sequence is also applicable for other data types. For example, I can create a list of numbers by using the variable d and assigning it the numbers 1, 2, 3, 4. When I run the print statement with the function type and pass the variable d as the parameter, the class list displays after I click run. Each time I assign a value to a particular variable, Python behind the scenes is automatically assigning the correct data type for that variable. In this video, you learned about the different data types in Python. I encourage you to start experimenting with these data types in your practice code. You may recall that Python can work with several types of data. In this video, you'll learn how to declare and use strings in Python. You'll also gain a general understanding of sequences and how to access individual items in a sequence. In Python, a string is a sequence of characters enclosed in either single or double quotes. As you may know, computers only understand binary code, which consists of ones and zeros. This means that characters need to be converted to a form that computers can interpret, a process known as encoding. Python uses a type of encoding called Unicode to communicate with computers. Strings in Python can be declared in several ways. For example, for a single line, you can type the variable name followed by an equal sign, and then the characters encased in quotes. If your string is too long for one line, you can add a backslash at the end of each line to create a multi-line declaration. When you run print on your variable, all those strings will be combined and appear on one line. If needed, you can reassign the value of a string. Say, for example, the variable name has a string value of John, but you want to change the value to Paul. This can be done simply by typing name equals Paul. Now, when you run print on name, this update should be reflected. It's important to know that a string is just a sequence of characters, which in turn means it is essentially an array. Each character in the sequence can be accessed based on its index. For example, Python strings use zero indexing, so you can access the first character with the number 0 in square brackets, or the number 2 to access the third one. If you need to check the length of a string, Python has functionality to assist you. You can apply the len function to a variable with a string value. This will then return a number that represents how many characters are in the string. Now that you've learned what strings are in Python, let's explore some code examples of strings in action. First, let me demonstrate the two ways to declare a string. The first method is by placing the characters inside of single quotes. So I type a equals and then hello in the quotes. On the next line, when I type print followed by a in parentheses and then click the run button, my code returns the string hello as the output. The second method is similar but uses double quotes. So I would enter it as b equals hello with double quotes. When I run the print function again, it also returns the string hello. Both quotation types are equally valid declaration methods. The choice is a matter of personal preference, but it's best to pick one option and use it consistently throughout your code. In addition to the quotation types, you can declare single-line or multi-line strings. An example of a single-line string can be a equals this is a single line. I asked to print out the value of a. When I run it, the value is printed out as I declared it. However, there may be cases in which a string is very long and you want to break it up into segments to make it more readable. To do that, I can use the / key to create a multi-line string. To declare a multi-line string, I type b equals followed by the string "this is a multi." Before continuing, I add a / at the end of this line. On the next line, I type the continuation of my string, line string example. Note that I enter a space before the word line, so that it's separated from the last word of the string on the previous line. And now when I run print on b, the / has the effect of joining both segments so that the output appears as a single string. Another thing you can do with strings is concatenation, which is the joining of separate strings. To demonstrate this, I first create two new variables, a equals hello with a space at the end, and b equals there. When I run print this time, within the parentheses, I type a plus b and get back both strings joined together. The plus symbol is usually used as an arithmetic operator, but when applied on strings, it combines them instead. And one more thing to know about strings is that they are considered collections of characters. What this means is that, much like an array, you can access individual characters based on an index, and you can also check the length of a string using the len or len function. To give an example, I create a name variable with the string value John. Now I want to print only the first character of this string. To do so, I run print on name, followed by the character index number inside square brackets. Strings in Python are zero indexed, meaning that the sequence count begins from 0. So 0 is the number that I place in the brackets. When I click on run, I get back the letter J. If I change the number to 3 and run it again, I get back the letter N, the fourth character in the string John. Next, let's check how many characters are in this string by using the len function. I start a print function, and in it I type len followed by name inside of parentheses. When I run it, it returns 4 as the length. In this video, you've learned about strings in Python. Specifically, you now know how to declare and use them, and understand that they are sequences of characters. See you in the next video. Python uses different data types to process and use information effectively. Sometimes you need to change the data type of a variable after you've collected values for it. Let's say, for example, a user submits a form on a website, and one of the fields was an integer, but the data was passed as a string. This is a problem because the only way to perform calculations with the number saved as a string is to convert it to an integer data type. To do this, you can use typecasting in Python. In this video, you'll learn about two different typecasting methods in Python. You will also learn to apply typecasting using the provided Python functions. So, what is typecasting? Typecasting is the process of converting one data type to another. Python has two different types of conversions, implicit and explicit. Let's explore each now in a little more detail, starting with implicit. Implicit data type conversion is performed automatically by Python's compiler to prevent data loss. It will convert, for example, an int to a float if it picks up that the inserted value is a decimal. It's important to note that Python will only be able to convert values if the data types are compatible. Int and float are compatible, but strings and int are not. So if data types are not compatible, Python will throw a type error. Alternatively, developers can perform typecasting with the explicit data type conversion. You do this by using the provided Python functions. There are many functions, but some of the most common are string, integer, and float. Let me take you through some of these functions and how to use them. First is the string cast function. This is used to convert any data type into a string data type. To use this function, you type str followed by the value that you want to convert between parentheses. Next is the int typecasting function. To use this, type int followed by the value that you want to convert between parentheses. The float function is another common type of casting function. Once again, you type the word float and add the value that you want to convert in between parentheses. Python has many more typecasting functions, and they also have a similar structure. They are odd, which returns an integer representing the underlying Unicode character; the hex function, which converts a given integer to a hexadecimal string; and oct, which takes an integer and returns a string representing an octal number. There are also tuple, set, list, and dictionary, which you will learn more about later in the lesson. In this video, you learned about typecasting in Python. It's important to remember that data types are not unchangeable. You can convert data types using the provided Python functions if you need to. Like other programming languages, Python focuses on taking inputs from users or other services and providing output. Python has many helper functions that make it easy to perform both of these actions. You may recall that you use the print function to output variables and other values. In this video, you'll learn more about the print function and how to use another new function called input. The input function is designed to get data from a source of input, and it can be used in different ways. For example, one of its most basic uses is when you use the input function to get data that the user types in the keyboard. This input can then be printed to the screen. In many cases, you want to get input directly from a user. For example, when you ask for a user's email address, let's say you want to use the input function to prompt the user to enter their email address, and then save that input to a variable called email. If you run this code, the user will be presented with a prompt to enter their email. The email variable will then contain the email address. Okay, let's switch back to the print function, which is used for output in Python. It can be used to print all different types of data, and it allows for more complex formatting. The print function itself accepts any number of arguments. For example, comma separated to print numbers in sequence, arithmetic to print the output of an equation, and string concatenation to join or concatenate two strings together. Python's print function also has reserved keywords that can be passed as additional arguments. These include objects, that is, values that are printed on screen, sep, which defines how the objects being printed are separated, and end, which defines what gets printed at the end. There's also file which specifies where values get printed to, and by default it is stdout. And lastly, flush, a Boolean expression to flush the buffer, which essentially just moves the data from a temporary storage to the computer's permanent memory storage. For example, suppose you can pass 3 parameters to the print function: the word hello, which is a string, the word you, which is another string, and sep, which is a built-in parameter whose value is set to a string containing a comma and a space. This will be used as a separator between the hello and you strings, and the output is hello, you. Often while programming, you need to know the value of a variable and output it onto the screen. Python allows for direct formatting inside the print statement. You can also control the order by specifying the numbers inside the curly brackets. For example, if you print the same statement twice but with the numbers switched, the output will differ. Let's move on to a more practical application of what you've just learned using some code examples of input and output. I'll demonstrate how to use input and output in Python. I'll begin by demonstrating the input function. I start by typing input, opening parenthesis, and closing parenthesis. I then click on the run command, and you'll notice that it runs the input function. And I'm provided with a console where I can actually type an input. So I type hello there, and I press enter. Nothing happens because I'm not actually collecting data. I'm just triggering the input function. And by default, it'll open up access to the command line or the console and allow me to input data. I can also add a prompt to the input function. For example, I can ask a question to the user such as, please enter a number. So I type, please enter a number in between the parentheses after the word input. First I clear the console, and then I click on run again. You'll notice that the output now asks me to enter a number. I type 5 and press enter. Again, nothing shows up from an output perspective. This is because I haven't actually done anything with the input value. I'm just demonstrating how the input function works. If I want to get the value of the input, I need to assign a variable. So I type in num equals input. Please enter a number. I clear my console screen again, and I click on the run button. It asks me for a number in the console, and I enter the number 6 this time. Now the num, or number, value will contain the number 6. But in order to see that, I have to output that variable to the screen. I can do this by using another function called a print function. So in this case, I print the number after the input itself by typing print, opening parenthesis, the abbreviation num, and a closing parenthesis. I clear my screen again and click on run. This time I type the number 7 when asked to enter a number. I press enter and you'll notice that the output prints 7. Now I want to show you that you can collect more than one input as part of the input because inputs work in a sequential manner. So I call this variable num1 and I enter another variable called num2 on the next line. The input for this variable is please enter a second number, and I just change the first variable's input to please enter a first number so that the instructions are clearer. I print out the value of num1 and num2. The print statement accepts both variables because they are separated by a comma, and it'll print out each one in that order. Again, I clear my console and I click run. I type 4 as the first number. I press enter and type 5 as the second number, followed by the enter key again. You'll notice 4 and 5 are printed out. You can also do arithmetic within the print statement. In other words, you can do addition, subtraction, standard multiplication, and division. So instead of using commas in the print statement, I type num1 plus num2. I clear the screen once more and I click run. I enter the numbers 5 and 4 again, and I get back 54. Now, this isn't exactly what I intended to do, and the reason is because both variables are strings. This goes back to what you've learned previously with data types. If I want to do the arithmetic calculation, I'll need to convert each variable into an integer first. So I can use the integer function on num1 and num2. I click on the run button once more and I enter the same two numbers, 5 and 4. But now what I get back is 9. If I want to see what type the input is, I can check the data type by using the type function. To do this, I type print, opening parenthesis, the word type, opening parenthesis, num1, followed by 2, closing parentheses. Let me just clear the screen. I click on run and enter the numbers 5 and 4 again in the console, and it says that the class is string and not integer, which is the type I actually want to do arithmetic. So just be mindful when you are using input that you will get a string. You'll most likely need to use the explicit data typecasting to convert it to the data type that you need. The print statement can also be used for concatenation. So instead of num1, I change it to str1 or string1, and I do the same with num2 by changing it to str2. Then I amend the input to read, please enter your first name for string 1, and please enter your second name for string 2. After that, I print out hello, and then use concatenation so that the user can be greeted by their first and second name. Now I want to run this program. I'll just clear the terminal quickly, and then I click on run. In the console, I type Tom for the first name and Jones for the second name. And the result is the output of hello Tom Jones. So concatenation can be used with a print statement as well. Finally, you can also change how you assign variables. You don't have to use concatenation, you can just use string replacement. I'm going to use a function within Python called format for this. Based on the order of the brackets, you can pass in the variables that you want it to be replaced with. In this case, string 1 and 2. Once more, I click run and I enter the username of Tom Jones, and hello Tom Jones gets printed. In this video, you've expanded your knowledge by learning about the input and output function in Python. An operator is a symbol that tells Python to perform a certain operation. You can think of them like road signs in real life. For example, suppose you're driving on a dangerous road and you spot an alert sign to reduce speed. Then you encounter a stop sign, and finally, a sign instructing you to turn right. You may not have realized that you were on a dangerous road. These symbols help keep you safe by instructing you to perform a specific operation. Similarly, when Python comes across an operator that you place in your code, it will also perform that specific operation. These operations can be mathematical, logical, and comparison. In this video, you'll learn about math and logical operators in Python. Most of the time, operators work on two values. Math operators are used for simple and complex calculations. It's essentially all the same options as the calculator would have. Let me explain this with examples of math and logical operators. The first operator I want you to know about is the addition or plus operator. The plus sign is a symbol that you must use when adding numbers together. For example, 2 plus 3. To subtract numbers from each other, you use the subtraction or minus operator. Use the minus sign to subtract numbers. An example of this is 3 minus 2. The division operator is next, and the symbol you use for it is a /. Division is an operation in which one number is divided by another. For example, 35 divided by 5. The last operator you need to know about is the multiplication operator, and the symbol you use for that is the star or asterisk key. Use this to multiply numbers with each other. For example, 7 multiplied by 4. Okay, now let's explore logical operators. Logical operators are used in Python on conditional statements to determine a true or false outcome. Let's explore some of these now. The first logical operator is named AND. This operator checks for all conditions to be true. For example, A is greater than 5 and A is less than 10. The second logical operator is named OR. This operator checks for at least one of the conditions to be true. For example, A is greater than 5 or B is greater than 10. The final operator is named NOT. This operator returns a false value if the result is true. For example, A is not greater than 5. Operators are usually combined with conditional statements to control the flow of a program that meets specific criteria. For example, let's say a restaurant gives discounts based on the following two conditions. Is the customer part of the loyalty program? And did they spend over $100? To determine this, you can write code using logical operators to check if the customer is in the loyalty program and if they spent over $100. You'll learn more about conditional statements in a later lesson. Now, let me demonstrate how to use Python, math, and logical operators. Math operators basically give you the same functionality as what you have on a standard calculator, so you can perform operations like addition, subtraction, division, and multiplication. I start with a simple addition example. I'm using the print statement, so the output displays on my console. I type print, and in parentheses, I add 2 plus 2. The value I expect back is 4. When I run the statement, the value of 4 displays in the terminal. For subtraction, I change the plus sign to a minus sign. I click on the run button and the value displayed is 0. If I subtract 2 minus 2, the answer is 0. For division, I change the minus sign to a /. I type 35/5 in the parentheses. I click the run button and the result is the value of 7.0. Just a note on this, the value returned is a float instead of an integer. Now let's cover multiplication. I change the / to a star sign that represents multiplication. I type 25*5. I click on the run button and get back the value of 175. That was a short introduction to the math operators. Next, you'll explore logical operators. Logical operators are used to control the flow of your application. The logical operators are AND, OR, and NOT. Let's cover the different combinations of each. In this example, I declare two variables. A equals true and B also equals true. From these variables, I use an if statement. I type if A and B : and on the next line, I type print, and in parentheses and double quotes, I type all true. You'll learn about the if statement shortly, but for now, just know that this print statement will only be executed if both A and B are true. The print statement of all true is displayed in the terminal. If I change the value of B to false and I run the statement again, nothing gets printed out. The reason for it is that the AND statement as a condition needs both A and B to be true so that it will print out the statement. Now let's cover the OR operator. So I'm changing AND to OR and I click on the run button. The all true value has been printed out again. The reason for it is that with the OR operator, if either A or B is true, the if statement is true. If I set the values of both variables to false and click on the run button, nothing gets printed out. This is because A is false and B is false, so the condition in the if statement has not been met. In this last example, I'm going to demonstrate the NOT operator. I'll keep the OR operator. Before OR, I type if not A in parentheses, then or, then not B in parentheses, followed by a colon. I click on the Run button and the value returned is all true. And what that's doing is it's looking for a negation against A. So not A is not false, which is true. And the or, a negation of B, which results in true. The or condition checks to see if either is true. Now I change the A and the B to be true. I click on Run and nothing gets printed out. The reason for that is that it's checking again for if not A, essentially if A is not true. In this case, A is true and its negation is false, so it's not going to meet that condition. Or not B also results in false and does not meet that condition as well because both are the negation of true. This is still not going to print out any value because again, none of the conditions are being met. And that's a brief introduction to using both math and logical operators in Python. Congratulations. In this video, you learned about math and logical operators. Great job. If you'd like to learn more about math operators in Python, there's an additional reading at the end of this lesson. In programming, it's important to understand how to control the order in which your code is executed. For example, suppose you're invited to an event. You have to consider whether you need to dress formally or informally. Another example of a control flow is to consider a light switch. The flow is represented by the electrical current and the control as the switch itself with the two states of on and off. The order in which you make decisions matters, and the same applies to writing effective programs. In this video, you'll learn how to use conditional statements to control flow in Python programs. So, what is control flow? Control flow refers to the order in which the instructions in a program are executed. All programs have decisions that need to be made. As a result of this, the program will take different actions or directions. In Python, there are two types of control flows. First, you can use conditional statements such as if, else, and elif, or else if. And second, you can use loops such as the for loop and the while loop. Let's explore these a little further now. The if keyword states that if the condition proves to be true, a function is performed. The else keyword catches anything which isn't caught by the preceding conditions. The elif or else if keyword is Python's way of saying if the previous conditions were not true, then try this condition. The for loop checks for specific conditions and then repeatedly executes a block of code as long as those conditions are met. The while loop repeats a specific block of code an unknown number of times until a condition is met. Let's explore conditional statements in more detail with some practical examples using the if, else, and elif. I'll now write some code for a restaurant that wants to apply different discounts based on the amount its customers spend. To start off, I define a variable for the customer's bill. I'll call it bill total and assign a value of 114 to it. Now I apply a condition with an if statement. If bill total is greater than 100, print the statement bill is greater than 100. Next, to apply a discount to bill total, I need to create a second variable. I'll do this above the if statement in my code, call it discount1 and assign a value of 10 to it. The condition also has to change. So inside the if statement, I add bill total equals bill total minus discount1. At the very end of the code snippet, outside the if statement, I'm going to print out what the value of the total bill is. To do this, I type a print statement that says total bill, and then a plus sign. To add the value of bill total here, I need to convert the integer to a string. I use the str typecasting function to do this. Let's click on Run. Great. In the terminal, two strings are printed. Bill is greater than 100, and the total bill is 104. But what happens if the bill is less than 100? I change the value of bill total to 95 and press Run. Notice that this time, because the if condition is not met, it only prints the statement total bill is 95. But I'd like to print a statement that says the bill is less than 100. To do this, I add an else statement below the if statement. I type else, colon, and in the next line, I print the statement bill is less than 100. Let's run the code. The output in the terminal now says bill is less than 100 and total bill is 95. Up to this point, you've learned how to use the if and else statements to control the order in which values are assigned and printed. You are now ready to take program flow one step further. Say this restaurant wants to add another discount for bills over 200. How would you do that? Once again, I first need to create a new variable above the condition that I name discount2, which I set equal to 20. If I run the code now, it will still print out the same output because I haven't changed any of the conditions or values yet. Let's change the value of bill total to 210 and click Run. Notice that both statements are printed, but discount 1 is still applied. It's clear that the if statement is still executed. Since the value is 210, the condition is still met. To change the program flow for values over 200, I need to add an AND condition to the if statement. I change the statement to if bill total is greater than 100 and bill total is less than 200. Let's run the code and see what happens. Now the discount wasn't applied. The output just says bill total is 210. Why? Because the condition is not met. Now this is where it gets really interesting. To add a second condition for bills above 200, I'll use an else if statement. In between the if and else statements, I type elif, which stands for else if, and then bill total is greater than 200. Print the statement bill is greater than 200. In the next line, I apply the new discount. I type bill total equals bill total minus discount 2. First, let me clear my screen so you can focus just on the results. Now I press Run. Notice how the program flow has changed. The first condition was not met, so the code went to the second condition where the value of bill total was compared to 200. And since it was greater than 200, the statement bill is greater than 200 was printed. The code then proceeded past the else condition because the previous elif condition was true. Remember, the else condition only executes if none of the preceding conditions are true. Finally, it printed the statement at the end of the code snippet, namely, total bill is 190. This proves that discount 2 was applied. Congratulations! You now know how to control program flow with if, else, and else if. Once you become proficient in using conditional statements, programming becomes a lot of fun. I encourage you to test it out. In this video, you learned how to use conditional statements in Python. Writing conditional statements is an essential part of programming, and I encourage you to practice them in your code. The next time you need to make a decision, think about the conditions involved and how they can be represented if you were to code them in Python. You may recall how to use the if, else, and else if statements to test a variable against a few conditions. But on some occasions, you will have to test a variable against many conditions. To deal with this, you can use something called a match case statement. In this video, you'll learn how to use a match statement as an alternative to an if statement. Now let's consider an example to compare the match statement to the if statement. Say you want to write code to print HTTP error messages according to error codes. To do this with the if statement, you would have to write the if condition, all the alternative if-else conditions, and finally an else condition. Conditional statements like if, elif, and else work well over a small number of conditions, but over a large number of conditions, your code can get large, complex, and messy. Fortunately, there is a cleaner way to achieve the same result using the match statement. The match statement in Python was introduced in version 3.10. Using the match statement, you can achieve cleaner, more readable code that allows all the same functionality as the if controlled statement. When using match statements, there are a few things to remember. You can combine several conditions by using the OR operator in the conditional statement. The default is essentially the final outcome if nothing is found in the case checks. It's the equivalent to the else in the if blocks. Let me demonstrate this example now using VS Code. Okay, so I've written a simple if statement that checks for an HTTP status code. If the value of the variable HTTP status matches one of the conditions, it will print out the equivalent message. I'm now going to add a match statement below the if statement. For a clear comparison, I will test the same variable against the same values. I type match and then the variable HTTP status and a colon. On the next line, I type case, which is the equivalent of the word if and the value of 200. On another line, I repeat the action used in the if statement for 200, which is to print the word success. So in other words, the variable is matched against the value of 200 and the if values are equal. It will print out the word success. Notice that the value of HTTP status is indeed 200 at the moment. So let's run the code to test how the if and match statements are processed. In the terminal, the word success is printed twice because the value of HTTP status is matched twice in my code run, once for the if statement and once for the match statement. Now let's change the value of HTTP status to 201 and run the code again. In this case, success is only printed once. Why do you think that happens? Because there is an OR condition for the value of 201 in the if statement, but none in the match statement. To do the equivalent in the match statement, you use the OR operator. So I place my cursor in between 200 and the colon and add an OR character and the value of 201. I clean my screen by using CLS and then click on Run again. Now success is printed twice again. So in the match statement, the pipe command is shorthand for if, or. The great thing is that you can add many case statements in a match statement. But what if none of the values match the variable's value? Now let's change the value of HTTP status to the value of, say, 550 and explore what happens. I click on Run, and this time the word unknown is printed. You may be wondering why that is. Because the else statement is like a catch-all. If the value does not match anything within the if or the elif statements, the default will be the else statement, which in this case has a print function for the word unknown. Well, the match statement also has a default class, and you add it by typing the word case _ colon, and on the next line, print unknown. Let's run the code again. Great, the output is unknown, which means that the default statement in both the if as well as the match statement was actioned. My match statement is coming along well, but it still needs a few tweaks to make it act exactly like the given if statement. To do that, I'll add a few more case statements that will test for the same values as the elif statements. I type case 400 colon, and then I add a print command with the words bad request. I add another case and the value of 500, and I also need to test for 501 like in the elif statement above. So once again, I add an OR character and type 501 colon. On the next line, I add the error message that I want to print, which is server error. The match saves a bit of space by combining the OR statement, so you don't have to do a comparison against a variable each time like in the if statement. Let's change the value of HTTP status one more time to 501. I just clear the screen again and click on Run, and server error is printed for both statements. Now you know that there are some differences between the two, but the match statement does exactly the same as the if statement. In summary, the match statement compares a value to several different conditions until one of these conditions is met. So you now know how to use the match statement as an alternative to the if statement to test a variable against many possible values. The match statement is relatively new to Python. Prior to version 3.10, developers had to get creative and code their own solutions. You'll learn more about those alternative methods later in this lesson. Have you ever come across a song that you like so much you want to listen to it again and again? You select the loop option so that you can listen to it repeatedly. This action of repetition is known as looping and also exists in Python. In this video, you'll learn to use looping constructs when the same set of steps must be carried out many times. Python has two different types of looping constructs for iterating over sequences, the for loop and the while loop. Looping is used to iterate through the sequence and access each item inside the sequence. Let's start with a basic example of looping using a string. First, you declare a variable called str, which is of type string. Recall that a string in Python is a sequence, which means you can iterate over each character in the string. A sequence is just an ordered set. Now let's break apart the for loop and discover how it works. The variable item is a placeholder that will store the current letter in the sequence. You may also recall that you can access any character in the sequence by its index. The for loop is accessing it in the same way and assigning the current value to the item variable. This allows us to access the current character to print it for output. When the code is run, the output will be the letters of the word looping, each letter on its own line. Now that you know about looping constructs in Python, let me demonstrate how these work further using some code examples to output an array of tasty desserts. Python offers us multiple ways to do loops or looping. You'll now cover the for loop as well as the while loop. Let's start with the basics of a simple for loop. To declare a for loop, I use the for keyword. I now need a variable to put the value into. In this case, I am using I. I also use the in keyword to specify where I want to loop over. I add a new function called range to specify the number of items in a range. In this case, I'm using 10 as an example. Next, I do a simple print statement by pressing the enter key to move to a new line. I select the print function, and within the brackets, I enter the name looping and the value of I. Then I click on the run button. The output indicates the iteration loops through the range of 0 to 9. It's important to note the 3 main points. The iteration starts at 0 based on the index of the item itself. Every for loop usually starts with 0. Most arrays start at 0. The reason for that is that it's the first item in an array or the first item in the index. In this case, the last item in the array or index will be 9. Now I want to change what I loop through. As an example, I'll enter a simple array above and call it favorites. To do this, I start by removing the hash sign in front of favorites. Next, I replace the range function in the current for loop with favorites to loop through. The I that I declared as part of the for loop can change to any value, and in this case, I'm using item. I now change my print statement to include item in my print loop. I also change the text to I like this dessert. I click on the run button to print the value stream. In this case, item calls each of the 5 desserts titles in turn, and our print statement combines them into a sentence. The next looping option I'm discussing is the while loop. The while loop differs slightly from the for loop. To demonstrate this type of loop, I first comment out the for loop on my screen. Let's start by using the while keyword. As in the for loop, I need to specify a condition to make the loop over n times, depending on the value itself. First, I need to declare a counter. I do this by typing count equals 0 above my looping statement. Next, I enter count after the while keyword, followed by the less sign and the word favorites. Now I insert the function len to provide the length of favorites. This means the loop will run while the count is less than the length of favorites. In other words, while it is less than 5. To print the value of the looping statement, I press the enter key to move to a new line. Then I select the print function, and within brackets, I enter the text I like this dessert. The key difference here is that I need to use the index to access the items within the favorite array. To do this, I type favorites and add count to represent the index. It's important that I now increment count so that it will essentially match the loop statement. If I do not increment count, I'll end up with what is called an infinite loop. This means it will just keep looping and looping until the compiler stops it from running out of memory. To increment the count, I press enter to move to a new line and add count plus equals to 1. I clear my screen and click the run button. I get the same print output as the for loop. It's important to note that in a standard for loop, I don't have access to the index, but I can use the enumerate function to do that. So I change my current for loop statement by adding idx, and it becomes for idx item in. Then I call the enumerate function with favorites in parenthesis. On the next line, to print the output, I replace the text I like this dessert with idx and click the run button. The results display the index and the value of the item within the array. Congratulations! In this video, you learned about looping constructs in Python using the for loop. In Python, nested loops can be used to solve more complex problems. For example, the nested for loop is written by indentation inside the outer loop. Let's explore this further now and break down how a nested loop works. First, the outer loop will start and then step into the inner loop. Then the inner loop will run until its range limit is met, 10 in this case. Once the inner loop completes, it will come back to the outer loop for the next iteration and then step into the inner loop again. This will happen until the outer loop has reached its limit. Now let's explore an example using nested loops to iterate over two lists. For example, suppose you have two lists of integers from 1 to 9 and a count variable that is set to 0. You again have two loops, the outer loop which will iterate over list 1 and the inner loop which iterates over list 2. If you run this code, it gives an output of 90. Let me break it down for you. The outer loop runs a total of 9 times. The inner loop runs a total of 9 multiplied by 9, which is 81 times. And 9 plus 81 gives a total of 90. To help visualize how this would look, you can make some minor changes to the loop to output what it looks like. Okay, so you now know that the number of times a loop is run is based on the size of the list. Now that you've learned about nested loops, let me demonstrate some code examples of nested loops. So I have VS Code open, and first let me start with a simple example and write a for loop. I type for I and I use the range function, so I have in range 10. Above the loop, I label it with a comment outer loop. This first for loop is considered an outer loop, and inside I will have an inner loop. I write a comment inner loop right under the first for loop. Now I type for j in, then I use the range function again, and I pass in a 10 and end with a colon. The 10 indicates the number of times the loop will iterate or repeat. In this example, I print out 0, and then I use end equals and a string with space in double quotes to ensure it prints out in an even manner. And lastly, I'm going to print out an empty line so that it goes to a new line in each iteration. If I run the for loop, the system prints out a 2D array grid. This is just to demonstrate how the for loop works. If I want to print out a single line, I can change the outer loop to 1. I clear my screen, run it again, and this time a single line of zeros is printed out because the outer loop only iterated once. This is all based on the outer loop only. It runs once, but when it goes to the inner loop, that it runs 10 times and prints out a 0 for each item on the same line. Every time the outer loop starts, it will go into the inner loop. The inner loop must finish before it comes back to the outer loop to start on 2, 3, 4, and so on. I can showcase that by simply changing the outer loop range to 2. In this case, only 2 lines are printed. So the first when I equals 0, it comes into the inner loop and prints out 10 times. When that's finished, it comes back to the outer loop. Then I is incremented again to 1, and then it'll be printed out from J's inner loop and another 10 zeros again. The other issue to consider with nested loops is the complexity, or what is commonly known as time complexity. The larger the array, the more time it's going to take to run my code. Let me showcase this by running a for loop for a larger range, but also putting a timestamp on it. I import the time module to put a timestamp in what's printed out. I class it as the start time equals time.time, which is the function that I want to call. The start time is initialized the moment I run the script. I also want to print out how long it took to finish. I do that by putting a print statement outside the for loop. I then calculate the time as in the time it took to finish and then subtract that from the start time above. This is going to print out many decimal places, so I use another function named round, which rounds numbers to a decimal of my choice. In this case, I round it off to 2 decimal points. Let me clear my screen one more time. I click on run, and it outputs the time of 0.0 seconds. This makes sense because the time my code takes to run is really short. Now let me increase the range in the outer loop to 100, and I also increase the range in the inside loop to 100 and I click on run one more time. The time now goes up 0.01. In this case, it's not a big difference, but when you're dealing with large data sets, this will have a huge effect on the running time of my code. This time, let's say for example that I keep the outer loop to 100, but I increase the inner loop to 1000. I clear the screen and click on run. The time increases to 0.04. If I increase the inner loop one more time to 10,000 and I clear the screen and click run, now the time goes up to 0.45. So the larger the array or the larger the range, in this case, the more time it's going to take for a program to complete. It's always important to remember how you can optimize code to make it run more efficiently, and consider the amount of time your code will take to run. You just covered nested for loops and learned about the issue of time complexity. In this video, you learned about nested loops and how they work.